Hello everybody. Welcome to today's episode where we'll be talking about implicit differentiation. Now, implicit differentiation is an extension of our chain rule, so we want to be real confident with our understanding of the chain rule before we move forward. Okay, we're going to start with a simple problem, and what makes it simple is we're finding the derivative with respect to x of an expression in terms of x. So we will be differentiating explicitly just using the power rule. In this next problem, notice that we are finding the derivative with respect to x of y squared. And in this case, the variable that we are finding the derivative with respect to is different than the variable of our expression. So now we're going to use implicit differentiation. With implicit differentiation, our variable y is defined implicitly as a function of x. So f of y can be considered as f of g of x, a composition of functions. So we're going to use the chain rule here. So dy dx of f of y is going to be the derivative of the outer function, f prime of y, times the derivative of the inner function, y prime. So let's see how that looks in our problem. So we're going to take the derivative of the outer function, so that's 2y, times the derivative of the inner function. The inner function is y, so that's the derivative of y is just y prime. And that's our answer. Now let's go ahead and practice a few of these. The first one, the derivative with respect to x of 4y cubed. The derivative of the outer function is going to be 12y squared, and then the derivative of the inner function y is y prime. In this next one, the derivative with respect to x of 2x minus 3y. Well, since we're finding the derivative with respect to x, the derivative of 2x is just 2. And then 3y, since y is a function of x, this is going to be 3, the derivative of the outer function, times the inner function, y prime, the derivative of the inner function, y prime. And finally, the derivative with respect to x of the product xy minus 3x. Well, the product xy, we're going to need to use the product rule, and so that's the first factor times the derivative of the second factor. The derivative of y is just y prime, plus the second factor times the derivative of the first factor. The derivative of x is just 1. And from that, we're going to subtract the derivative of 3x, which is just 3. Now we're going to look at a slightly different problem. It's going to use a lot of the same skills we just looked at on the previous slide. But our problem here is to find dy dx, or isolate y prime. And the steps we're going to go through are we're going to differentiate both sides of our equation with respect to x. Then we're going to separate our terms, everything with a y prime on one side, anything that doesn't have a y prime factor on the other side of the equal sign. And then we're going to solve for y prime. That's really what we're looking for, is y prime. So let's start with step 1. We're going to differentiate both sides of our equation. So 2y, that's going to be the outer function derivative, is 2 times the derivative of the inner function y prime, minus, and then we have 3y cubed. So that's going to be 9y squared, the derivative of the outer function, times the derivative of the inner function, y squared, that's going to be 2y, and the derivative of the inner function. And then 3x squared, that's in terms of x, so that's just going to be 6x, and 7 is going to be 0. Now for step 2, we're going to separate the terms with a y factor on one side of the equal sign and all the other terms on the opposite side. So if you look at step 1, you can see that the terms with a y factor, or y prime factor, are the first 3 terms. And this last term, 6x, doesn't have one. So I'll separate my terms like this. The third step is to solve for y. Before we can solve for y, we want to first factor out y prime. I'm sorry, we're solving for y prime. So if I factor a y prime out of the left side, I'm left with 2 minus 9y squared plus 2y. And that still is equal to negative 6x. And our final step is to isolate y prime. So we're going to divide out its factor. So it's going to end up with negative 6x over 2 minus 9y squared plus 2y. And that is our dy dx. This next problem, we need to find the slope of the tangent line to the equation at a point. So our first three steps in this are the same as what we just did. We want to find y prime because y prime is dy dx, which is equal to the slope of the tangent line. So now let's move into our 4 steps to finding dy dx implicitly. First, we'll differentiate both sides of the equation with respect to x. So that's 4x minus 6y. Now we have to use implicit differentiation here because our variable is y. So we're going to multiply that by the derivative of the inner function. And then 14, the derivative is 0. Now for step 2. Step 2, we're going to separate our terms. So I'll just add 6y times y prime to both sides. Now for step 3, where we solve for y prime. So y prime is going to be 4x over 6y. And in our final step here, step 4, we're going to plug in the point into our derivative equation here. So y prime at the point 1, 2 is going to be 4 times 1 over 6 times 2. And that is 4 over 12, or 1/3. And that's the derivative, which is the slope of the tangent line to the equation at the point 1, 2. Next, we have another problem determining the slope of a tangent line. So let's first differentiate both sides. So notice in this problem, it's a little tricky. We're going to use the chain rule. So it's going to be 3 times 4, and that's our outer function. Reduce the exponent to 2. And then we're going to do times the derivative of the inner function. So let's see what that looks like. So we get 12 times x squared plus y squared times 2x plus 2y times y prime. And then in our other side of the equation, we're going to use the product rule. So this is going to be 32 times x times y prime plus y times 1. Now let's carefully expand our equation. There we go. And we want to identify the terms that have a y prime factor in them and organize our equation so that those are grouped on a single side of the equation. Then we will factor out a y prime from each term on the left side and then solve for y prime. So that's our dy dx, or y prime, and our final step here is to find y prime at the point 1, 1. So we plug 1 into x and 1 into y, and finally we can simplify that, which becomes negative 64 over 64, which is negative 1, which is the slope of our tangent line at point 1, 1. Now we're going to use implicit differentiation to find a second derivative. So given the equation, find the second derivative, and we represent this as d to the second power of y over dx squared. And the way we find a second derivative is to take the first derivative and find the derivative of that. So let's start with dy dx, which is equal to y prime. So that's going to be, let's see, 2x plus 2y times y prime equals 0. Next, we'll separate the y prime term from the non-y prime terms and solve for y prime. So y prime is going to be negative 2x over 2y. And last, we'll evaluate y prime at negative 2, 3. So that's going to be negative 2 over x, which is negative 2, over 2 times y, which is 3. And that gives us 4/6 or 2/3. And that's our first derivative. Now let's find our second derivative, which we can also call y double prime. Now our derivative is going to be, our second derivative is going to be the derivative of the first derivative, and we have a quotient here. Our first derivative is a quotient, so we're going to be using the quotient rule. So our second derivative is going to be the denominator of the first derivative squared, and then the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. Now be careful here. This is going to be the outer function, 2y. The derivative of that is 2, and then times the inner function, y prime. And we'll simplify that. And next we will evaluate that second derivative at the point negative 2, 3. So we put into our second derivative, into y, we put 3, and into x, we put negative 2. But we have this y prime here. What do we put into y prime? Well, notice that y prime at negative 2, 3 is 2/3. So we put 2/3 in to the first derivative. Now we'll simplify that, and that comes out to be negative 13 over 27, and that's our second derivative. Our last problem of the day goes beyond finding the slope of a tangent line to finding the actual equation of the tangent line at a point. So first we're going to differentiate our equation. So our equation here is going to be, the derivative is going to be 1/2 x to the negative 1/2 plus 1/2 y to the negative 1/2 times y prime plus 0 equals y prime. Now let's organize our equation so that the terms with a y prime factor are on one side and the terms that do not have a y prime factor are on the other side of the equal sign. And there we have that. And next we will factor out a y prime from the right side of the equation. And then we will solve for y prime. And now that we have our y prime, we can plug in our point, and then we will simplify that. So the slope of our tangent line is 2/3. Now we're going to use point slope form to find the equation of the tangent line. So recall point slope. That's y minus y1 equals the slope times x minus x1, where x1 and y1 are a point on the line. So plugging in our point, we get y minus the y coordinate, 4, times the slope, times x minus the x coordinate. And you can leave it just like that. No need to put it in intercept form.